So, welcome to the next video. We stopped here where we analyzed our items and we understood that they're perfectly consistent and actually measuring what they have to measure. So we made a very simple discriminant analysis and discriminant validity and convergent validity test, but just by displaying that the things measure what they have to measure. In real life, you have to run additional tests. There is HTMT, hetero-trait, mono-trait test. There is average shared variance, maximum shared variance test, but you need to dig deeper. And by James Gaskin, he explains how to calculate them using the specific Excel tool that he developed and Amos. So now we have here 7 items, but actually we need not the 7 items. We need to have one. We want to see whether anger has impact on behavioral inhibition scale. And for this, we need to aggregate them. And procedure is very similar to what we've done before. We go to factor analysis. Remember, we did it. Now we remove all these items from here, and now we add only the items that we want to aggregate. We know already from the previous test they were good. Now we just need to save one variable out of them. We add them here. All things are equal, so by rotation it is direct oblimean, by extraction principal component analysis based on eigenvalue, and by options we have support small coefficients. It doesn't really matter for now. Now we go to scores, and in scores we save it as a variable. It will make one variable, one regression variable from all the 7 items, and it will be mean centered. It means it will be 0 in the middle, and 1 would stand for 1 standard deviation, so it will be standardized mean centered value. If you need to know more about it, you need to search on the internet. It is beyond the scope of this video. And if we are done correctly, this variable will just be saved and will appear at the end as the joint variable for all 7 items. Why it is important to run this procedure? Why not just taking the mean of all items? Because these items have different loadings. Some of them are more important, some of them are less important. It means if you just take an average of all these items, it will be close. The results will be very close to the to this regression saved variable. But this is the correct one, which takes into account the loadings on the final latent construct. We repeat it now for all other variables, and then I'll show you where they appeared. Now we take the plus RR and click on OK. So it's ran again, as you see, good loadings. Now all numbers are positive because we work with only one variable. It doesn't look at correlations among or between the latent scores. So we add also this one here. Click on OK. As you see, all perfect. And the last one is the FF. We add them here and click on OK. So it has done something, at least it says it has saved them. Now we go to our file and look at this one. We have now 4 factors at the end. We just need to call them correctly. So this is BIS factor. And if you want to be more precise, you can write principal component analysis. Direct oblimean, so you can make it more precise. Depends on your analysis. For now, we don't need it. This one will be BIS. I think the first one was RR. Then we have the BISD, and okay, we need to add here factor because we need to know that it is the aggregated variable, that we just are aware that it is an aggregated variable, and this will be BISFF factor. Select these variables, copy, paste them here because this is not treatable. It explains that it was a regression factor. We just make it like this. And now we are ready to start with the analysis. We have now aggregated the factors. If you click on them, you will see how they look like. This is this aggregation as a regression. And minus 0.29 means it is 0.29 standard deviations away from the 0, which is now in the middle, which is fine, which is interesting. So just to show you how it works, we go to descriptives. And if I take now, instead of h, these new variables, they will have all 0 as a middle and standard deviation of 1. This is called standardization of variables. And you see, mean is always 0, standard deviation is 1. So it standardizes them. And now we are ready, actually, to start the analysis, and we'll do it in the next video. So, see you soon.